studies we have done within the same project. Also, I should, we don't have slides here. Yeah. So I should also note that basically Christian, Andres, and Anna Maria is the engines of this project. So they've developed most of the project. So they should have the all credit. So I'm just presenting our preliminary results. So this is a ongoing work to be completed by March. Just the content of the presentation, but due to time, I'll go quick. As in other countries, the road freight transportation is the transportation as a whole is the largest has the largest share of man-made greenhouse emissions and has been steadily increasing since the last decade. Half of these emissions in transport came from the freight transportation. This is not just due to the share of the volume of the transport, but also due to the use of diesel, the low quality diesel fuel, and also the poor state of vehicles. So these are the disadvantages that Colombia has contributing to emissions more than others. It has also advantages. One of the, for example, hydropower countries. So in the future, I think they can overcome this and become net zero by 2050 or before that. Colombia government is quite committed to achieve net zero in road freight transportation. They have very strict targets by 2030 and mid-century. And these projects, basically, we are working with the ministry, the planning department, associations, unions, drivers. So we contribute them, developing policy brief, tools, various tools, decision-making tools, and also basically we train and we run workshops regarding eco-driving and in other aspects. So as I said, Colombia is committed to achieve this. And basically, there are multiple ways we could contribute. And one of them is basically about the fleet renewal of the Colombia fleet to achieve net zero. If you look at from the macro level, basically there are many uncertainties, risks. This is not very different than other countries. There are multiple stakeholders. They have conflicting objectives, so each are blaming each other. So the technology is not there yet. We know the companies are waiting to have the best technology, so they could spend the least amount of money, take the minimum risk. There are conflicts between governments and authorities. Unions are very strong in Colombia, so it's not easy to make changes and apply it in practice. We had pandemic, so it has an impact on this transition. There's also the budget issues, incentives, and also there's a misaligned interest between international commitments. So from a macro level, it's the same, and basically it's not very different than other countries, what can be done at macro level. But in this project, we want to look at from the macro level, work with the companies and to develop them, tailor them, specific fleet renewal plan. So basically, if you go to companies, I think it's the same for the UK, they are waiting. So they don't really want to invest now. They're waiting 2030 to change their fleets and become net zero. For the Colombia, it's similar. They want to basically wait, of course, and basically spend and take the risk. But now with this tool, we came up with the plan for a specific company, so they can adapt make their investment plan accordingly based on the plan. Our research differs from different perspectives. So basically, we purely focus on the freight transport. We don't look at the passenger side. We look at operational efficiencies, and also we look at the strategic investment. This is for the basically we consider the whole horizon until mid-century, so until 2050 from today. We use real data, and also we spend so much time understanding the requirements of Colombia and also the practicalities. So the local practicals, some of them are quite different than other countries. So we observed 4 gaps in the literature. There are many simulation studies in the literature, but we couldn't find any specifically focusing on road freight transport decarbonization at macro level. We also couldn't find any model which looks at both operational and the strategic level decisions together. So we look at a couple of things. We look at the policies, because we also talk to ministry and the planning department. So we write policy briefs for them. So we know what they think, what they want to implement. We work with the companies. We have the company data. And also from this literature, we also know how the technology evolves regarding different options. And also we apply this on the real data. So eventually what we want to achieve, the strategic renewal of the vehicle fleets for the Colombian companies by looking at different technologies that can achieve both emissions reductions and also cost savings. This is the general methodology which we used in our research, but this can be also applicable for the micro level scenario planning, but also we use for the detailed plan for the companies. What it has, we have data. I'll briefly explain. Colombia is, we are very lucky because in Colombia, something called RNDC, so they keep track all the traffic movements. So all the companies, when move any freight from A to B, it's recorded. I haven't seen it in other countries. I think in the UK also we don't have it. So basically by looking at this data is publicly available. So you can see if you know the vehicle's plate, so you can check this historical data, how much load they carried, when they carried, etc. We know the policies, regulations, incentives. Also, we have the data regarding the technology. So what's going to happen, their efficiencies, their maintenance costs, etc. So what we look at the time horizon until 2050. We have different adoption rates of different technologies, but we focus on these two areas. One, operational practices, because if you look at from macro level, you are missing the operational level issues, because you cannot adapt. You cannot say, let's become, let's move to battery electric vehicle by 2030. So it takes time. So they have to know this time. Could be different for different companies, and this should be depend on their operations. We can learn from their empty trips. Like I said, we have the data. We can also look at the cargo consolidation. We can look at the driving conditions, and we can match it with the technology. At the end, we have this output, emission saving, fleet compositions, the number of vehicles scrapped. Today, we've seen countries, the age of the trucks varies. In UK, I think 12 years, the age of truck. In China, less. In Brazil, I think similar, but in Colombia, I think it's 18 years old, more or less. So there are some differences from country to country. So there are these two components. So we combine in this methodology, operational practices, which briefly explain what we have been doing. So empty trips, synchronization, consolidation process, and the efficiency level. So basically all these are represented in the model, and we match with the technology. In technology, we mean the diesel vehicles with higher Euro standards, Euro 6. We have electric vehicles, and also we have the fuel cell and LNG. LNG is also option in Colombia, so it was part of the technology. So this is the micro level model. This is a simulation tool, but we actually solve mixed integer linear programming formulation. The objective is the NPV, net present value, of the strategic investment in the future, because the company can make investment now or can make investment 5 years later or 10 years later. So we have to translate to the current cost, and we want to minimize this. That depends on the purchase cost, that depends on the fuel cost, that depends on also maintenance cost, because each technology requires different maintenance cost. We consider the initial investments because that's also important, how much budget the companies allocate for this transformation, the number of current vehicles, their age, their status, their maintenance status, etc., all included in the model. Also, we have the targets 2030 and 2050 targets, and eventually the model tried to reach zero at the end of the year 20. We have all other constraints as well related to assets, maintenance, because we are using the data and we are projecting the future, as you can imagine. We also need to assume the growth because the company assuming growing in the future, so there has to be also reflected. Let's assume now they're covering 1 million kilometers, but it might change next year. So we also consider those changes. We, from economic perspective, we consider the interest rates and also we consider the inflation. But as you can imagine, I mean, we are not fortune tellers, so we make assumptions. I wish we knew what would happen by then, but these are just assumptions in the model. So this is the RNDC database I mentioned from Colombia. Basically, it's from since 2015, and we look at the data from 2019 to 2022. So basically, this database represents 23% of all movements, consists of approximately 30 million trips, and there are 8 million records. So this is actually amazing and available for you to use. This data has been used by companies, cargo owners, carriers, and government authorities. And also we developed a couple of dashboards. Also, the ministry is using the dashboards developed in this project. This is one of the company. They are food processing company. They are specialized in biscuits, chocolates. I wish we had some so we could give you some samples. But it's a medium-sized company. It is one of them. So we can adapt. The plan is we have the model, so we have the RNDC data. So we go to companies, we ask specific information about their fleet. Then we go back to RNDC data, we extract the data, and we run the simulation. So that's how it works. That is just one sample. Like I said, this is a working project. So this is just small size or medium sized company. We got from them license plates because we can find the vehicle in the database. So we can see how much kilometer driven, how much payload carried, etc., based on this plate. Model, age, fuel type, capacity payloads, average mileage, etc., all can be found in the data. If not, we could ask the company because we work them together. There's a QR code, but this is the tool we developed, like I mentioned, macro level planning based on the 13 decision variables. So these are more operational level regarding, for example, aerodynamics, driving habits, etc., and their impact on the decarbonization strategy. Here, business as usual, and the target emissions if you want to achieve zero emission by 2050. And these are the technologies we consider. Diesel trucks, new, natural gas, electric trucks, hydrogen, and also we consider the scrap because at the end of its life, the vehicle needs to basically disintegrated from the company. But this, like I said, this is a macro level. So this might not be very useful for a specific company because, I mean, you can say this and you can adapt this for their fleet, but it wouldn't be realistic. So the idea, can we look at their operational data, combine with this, and have a tailored plan for each company? It works. These are a couple of outputs from the research. The first one, so if you remember, we had two types of vehicles, light duty and medium duty. And these are the vehicles needed for the company until 2050. So type 1, type 2. Because of the data in the beginning, even they didn't need that much. They needed 21 vehicles, but actually 19 vehicles was enough based on their data in the database. Because of the COVID, there was a reduction, 15, I think 20%. So that was enough. But After the year 5, you could see they need to basically increase their fleet size, get more vehicle, based on the assumption that the demand will go up. This is just a summary figure also showing how this company will move to alternative fuel vehicles. This one, the blue one, represents the diesel vehicles. The next one, you can see LNG. That's an option in Colombia, hydrogen. And then this big part is the electric vehicle. So based on this, the company can plan. They start with diesel. They can start with electric vehicle as well, as you see, LNG, hydrogen, and then continue with electric vehicle. But because we put them together, both light duty and medium duty, looks a bit complex. So let's look at separately. So this is the vehicle type 1. This is the light duty, and this is the medium duty. For the light duty, our projection is they'll have diesel, basically, and the diesel will stay in the system until year 60, because, like I said, age of trucks is around 18 years. So it's not easy to just remove diesel from the company. But here they can start adopting electric vehicle since year 5. And in midterm, hydrogen is also a viable option. But this is for Colombia. Like I said, they have hydropower. So green hydrogen is possible for them. It's different than the UK. So that's why they can look at the both. If you look at the second type of vehicle, medium vehicles, here you can see again the diesel, but you can see the share of hydrogen increase. This is also reasonable because hydrogen basically fits better for the medium and heavy duty vehicles as an option and has a higher share compared to light duty. This is the replacement cost. Here we have AFM. I mentioned the purchase cost of the technology, either electric, hydrogen, natural gas, or the diesel with new fuel type. We are also including this driving operating cost, so that cost actually be more comprehensive. We have fuel based on the energy consumption and the maintenance. So here, over the years, you can see how much the company needs to invest for each category. Normally, the biggest share, the purchase cost. And when they purchase cost, they don't buy as a lump sum. So what they do installments. So they lease or they use other financial models. And in our model, we also consider that. Here you can also see all together from different perspective. From CO2 emission perspective here, at the beginning, we have big emission saving as expected, and ultimately we are trying to aiming 0. But here, a couple of years, normally there's no big difference and then drops. That's about the adoption rates because it takes time. The company cannot invest new technology and buy new vehicle every year. So it's a process, it's a transition. And this is based on the data from today, but as you go over the years, the model can rerun. So you have better data. Imagine, for example, we have maintenance cost, but we don't know much what will be the maintenance cost electric vehicle in the future. It might change. Probably it will go down, but these are all variable. And when we are closer to mid-century, basically we'll see some changes, and it can change the plan. So this robust model, it runs fast. It's a complex model, but we can run it for small and large size companies, and gives, I think, good plan. At least the company can start with. Basically, it's like I said, it's hard to start with the micro level kind of plan. There are many variables, incentives, interest rates, subsidies. So these can change over the years. In the short term, basically, also what we observe, it's important to focus on the operational efficiencies and logistics optimization. Here we talk about consolidation, payload consolidation, and also minimizing empty trips, for example. What else needed? We need more research to understand the different type of vehicle technology. There are lots of reports, but we need more comparison to make better decisions if you want to select among them. And also, it requires a joint effort from government, industries, and public sector. So that's we try to do, bring all stakeholders together to achieve net zero. But I think it's a good maybe example from Colombia. So it's same in other countries. It should work the same. And we can also include here the energy sector. I think they are also important. Yes. Well, thank you.
Thank you, Imre. I think we've